This video outlines a method for carrying out column chromatography. You may be given slightly different instructions when you do this in the lab, but the principles will be the same. First of all, a small piece of cotton wool is placed in the bottom of the column to prevent solid material from going into the tap. Different columns may have different types of tap, but obviously the idea will be the same. Next, a small amount of sand is poured in to a depth of about 1 centimetre. Here you can see the sand forming a level surface on top of the cotton wool. We then take the appropriate amount of silica in a beaker, and this is then made into a slurry using the solvent we're going to run the column with. This solvent is known as the eluent. Here you can see us swirling the silica with the solvent before pouring it into the column very carefully. Again, a funnel should be placed in the neck of the column to assist with pouring. And you will need to occasionally swirl the beaker to ensure that the silica doesn't settle out in the bottom of the beaker. Where appropriate, more eluent should be added to reform the slurry to assist with pouring. You may need to do this several times. Should the level of the eluent get close to the top of the column, then some of it should be removed by opening the tap. We can run this into the beaker, which will then assist us in making a slurry with the remaining silica. And finally, we've transferred all of our silica into the column. Now we need to run some of the eluent out of the column so that it comes down to the level of the silica. It's crucial that you don't allow the silica to run dry, so you need to keep a close eye on the level of the eluent and close the tap at the appropriate moment. Here you can see we've run the eluent down to the correct level so that the top of the silica has not dried out. The next stage is to load our crude compound onto the column. First of all, we need to dissolve it in a small amount of the eluent. It's important to ensure that all of the crude compound has been dissolved. And then the resulting solution can be added to the column using a glass pipette. Here you can see the solution is being added evenly around the sides of the column. Now we add some sand to a depth of about 1 centimetre on the top of the column. This will protect the silica as we add eluent. And here you can see us topping up the column with eluent. And we're now ready to run our column. So we open the tap at the bottom of the column, and this allows us to collect our first fraction. In this case, we're collecting the fractions in test tubes, but depending on the size of your column, you may use sample vials or even conical flasks. Once collection is complete, we can close the tap momentarily to move on to collect fraction number 2. This process can be repeated any number of times to collect as many fractions as are required. Because our compound is coloured in this case, we can actually see it moving down the silica. This will give us a good indication as to when it's actually eluting from the column. In cases where you can't see the compound because of any colour, you can use TLC to analyse the fractions to identify the presence of different compounds. And as the level of the eluent approaches the sand, it's important to make sure that you top it up. We can then continue to collect fractions, and in this case you can see that the yellow band in the silica is approaching the bottom of the column. If we look closely at this particular fraction, we can see that the solvent has a yellow colour, telling us that our compound is eluting. Of course, in other cases, as mentioned previously, you'd have to use TLC to identify the presence of a compound. And here we have a full set of fractions. We can now collect any compounds that are present by removing solvent, and this would most commonly be done using a rotary evaporator.